For this limit, instead of using the L'Hopital's rule to only realize you gotta do it again, what if there's a faster way? What if you could do this in a minute or less? Because check this out. I'm going to take the conjugate of the numerator. And what is the conjugate in case you haven't heard of that term? When you have the square root of an expression, I'm going to call a minus a constant b. Then you take the square root of a plus b instead, and you multiply everything by that on the top and the bottom. And the reason why is that when you have two expressions multiply on the top, where the difference is the minus and the plus, it becomes just a squared minus b squared, right? And so the square root's going to go away for this part, and then the constant's just going to be squared. When you simplify the numerator even further, like ninjas, you're going to end up with just x sine of x on the top. And because the denominator also has an x, but it's x squared, I'm going to just ninja chop the top and the bottom by taking out a common x term. And that's going to give me this expression. And check this out. Remember that for a limit, when you have a fraction like this, you can actually break it up into easier limits and you multiply the results. Well, I'm going to break this up by first taking the sine of x over x part and making that its own limit, and then multiplying the rest by its other limit. And the reason why I'm doing this is because I recognize that sine of x over x is very familiar. That is a very famous limit that you should know by now is going to be a value of 1. And you can check out the video above for more info. And then for this right-hand side here, easy peasy, because we no longer have to worry about dividing by 0, because after I plug in 0 for x, on the denominator here, everything is going to cancel nicely, giving me this final answer.